Hello everyone. We will now discuss about distance and displacement. The simplest way to understand what we mean by distance is to jump to an example. So suppose we are at location A, which is here, and from here we move to some location B, which is here. Okay. We can move from A to B in a different manner. The first and simplest manner will be in a straight line. So we can simply go in a straight line like that. Second way we can move is possibly like a triangle. So we can go here first, and then from there we go northward like that, and then we can still arrive at B. The third way is our path number one. So path number two. Another way could be a very random motion. We can just move around everywhere, and then we arrive at B, right? So the distance is nothing but how much we have traveled from A to B, and really it depends upon the path, right? The distance is going to depend upon the path. So for example, let's consider path number two. First, let's say we move from A to B to this location. We call it C, and let's say this is 4 meters. And from B to C, let's say this is 3 meters. Okay. So the distance which we traveled while doing the path 2 was 4 meters plus 3 meters, and total is 7 meters. Now coming to the path number 1. Path number 1 distance we can find out by using geometry. So it is a right angle triangle. So using Pythagoras theorem, we can say this distance from A to B in a straight line path is going to be root under 4 square plus 3 square. That's going to be root 25 or 5 meters, right? So when we are taking a path number 1, the distance we traveled is 5 meters. And path 3, as you can see, we'll have to make an effort by putting scale in a very small straight line, and finally we can measure. So let's say that's around 20 meters. Okay. The path 3, the distance which we traveled is 20 meters. Right. So really it depends upon the path. How do we move? And that is what we call distance. It has a unit. In SI unit, it is meters. We can also convert it into centimeter, kilometer, miles, whatever we like, using some conversion. The displacement is actually much simpler than this. If you want to know what the displacement is, we simply take our initial location, which is A, and this is our final location. So I'm going to call this initial location, and we're going to call this final location. We simply join it by a straight line like that, and then put an arrow like this, right? So which says that we actually move from A to B, not from B to A, right? So we join. So this is really a straight line distance, right? Distance, as you can know, it is also going to be equal to 5 meters, right? Your displacement is also going to be 5 meters. But when we define displacement, we also put an arrow which signifies we move from A to B, and not like this from B to A, right? We haven't moved from like B to A, but from A to B. So we are going to say in the direction something like this, right? We can write it like north, east, east, or whatever we want to say, something like north, east, east, like that kind of a direction. Or we can also represent with some angle theta. So we can also say 5 meter at some angle theta from east. Okay. So what we understood is that the distance actually depends upon the path we take. It's the actual distance which we travel. The displacement is simpler, and basically we can simply calculate that by moving in a straight line from A to B. That is our initial position to the final position. All we have to do then also provide in which direction we move, right? So for example, for simplicity, we can say, let's insert on the slide, right? So we say we were here and we have now moved here. Let's say this is 5 meters, right? So distance which we have traveled here is 5 meters, and displacement is from initial position to the final position. Displacement we have to say 5 meter towards east, right? Or 5 meter eastward, right? So whenever we talk about displacement, we provide two information. One is the magnitude, or what we can say how much right? And then the direction. Without these two things, the displacement is not properly defined, right? So magnitude and direction both are provided, and that's what we call displacement. As you can see, it is represented by an arrow, so it is also a vector quantity, right? So displacement is a vector quantity, and distance, we are only interested 5 meters. We are not saying east, west, north, right? So again, if we move from here to here, this is also 5 meters. What distance we traveled, it is also 5 meters, but now the displacement is going to be 5 meters north, right? Because we moved north, right? So it's a vector quantity, and distance is a scalar quantity. Okay. So now we, to understand this difference, we are going to take one example question, and let me walk you through that. That will make understanding of this very easy for you. So here is an example. A car which starts at point A travels a distance 2 kilometers east to point B, and then travels a distance 2 kilometers north to point C. To understand this, it will be easier to draw the diagram. So I'm going to draw it. So first we are going to say we are at location A, and it's going to travel 2 kilometers to east, which means rightward. So roughly rightward 2 kilometers east to point B, and then a distance of 2 kilometers north is upwards, further north. Okay, this is point C. This is also 2 kilometers. Okay. What is the position vector, magnitude, and direction of car at B? So when the car is at B, it is asking relative to initial position A, what is the magnitude of position vector? So as you can see here, the magnitude is 2 kilometers and the direction is east. Okay, so this is our displacement or position vector with respect to A to B. Now, what is the position vector of car at C? So position vector is simply going to be the displacement vector, which will look like this. Straight line from A to C, and we have to measure from position number A. So in order to know that, we'll again use Pythagoras theorem. This distance is going to be 2 square plus 2 square, which is going to be root under 8, right? So this is going to be root under 8 kilometers, or we can also write it like 2 root 2 kilometers. And this direction, both of them are the same, so this is going to be north east. Fine. Now, what is the total displacement of car from A to C? We simply join from A to C straight line, which is just what we calculated. So this is also going to be the total displacement, which is going to be 2 root 2 kilometer northeast. See, we are providing two information, the magnitude and the direction. So whenever we are talking about displacement, we are interested in the magnitude as well as direction. Until you provide both of them, this is incomplete. Now it's saying what is the total distance traveled from car A to C. As we know, the distance traveled really depends upon the path, right? So the path the car took was first it went from A to B and then from B to C. The total distance is traveled from A to B. A to B is 2 kilometers, and then from B to C, 2 kilometers. So total distance traveled is 4 kilometers. Okay. So this is how we calculate displacement and distance, and the difference I will again summarize very quickly. The distance traveled is going to depend upon the path, right? And we simply sum up the straight lines to arrive at that number, whatever that number is, 2 kilometers, 4 kilometers, 6 kilometers, 10 kilometers, right? And that's it. Displacement is simply a straight line distance, or as you can see, the shortest distance from my initial position to final position. Okay, and then we draw that straight line like that, and then we put a vector sign of it to show in which direction it moved, right? So the direction is also important. So this is how we can distinguish between displacement and distance.